Hi, my name is Vesna. I'm from Belgrade and Amsterdam. I work for the RIPE NCC. Do you hear me? Is this a good use of microphone? Okay. I have a long-standing connection with the hackers community, although not really practical, but my friends are in CCC and other hackers groups. And my goal today is to make you interested to get involved in creating the addressing policy and creating internet standards. The internet is old. And it has been a great success. It grew very, very much. And it's now overgrowing its success. So soon it will probably be replaced with something even better. But in the meantime, we have to see how can we make it continue growing. So to connect more and more people and devices to the internet, we need more addresses. Right now, we have 32 bits in IPv4 address, and that is not enough for everyone. The shortage of IPv4 addresses has been predicted and planned for many, many years ago, and the immediate solution was to use private addressing. So a lot of hosts are now hiding behind the nets and so-called network address translators. But the next solution is to use bigger numbers. Well, yeah, the numbers are bigger, but the problems are still there. The problems are still the same. So how does this work? Well, there is a finite pool of addresses, and that is being distributed centrally from IANA. They are in charge of the whole address space, and then they give big blocks of addresses to regional internet registries. So in Europe, that is RIPE NCC, in Amsterdam, where I work for. And then regional internet registries, they distribute those addresses to local internet registries, their members. And there are around 6,000 local internet registries in Europe. I'm assuming that all of you are familiar with CIDR, classless interdomain routing. And if you are not, or if you like to keep this little handy paper with you, you can pick them up later. So the CIDR, the classless interdomain routing, made it possible to use this classless distribution of addresses. So using the flexible addressing, so making it possible to split the address at every bit, made it possible to chop the address space into small chunks and to use as little as possible, to be conservative when using addresses, but it also enabled the route aggregation. So that is very important for announcing as few as possible routes to the public internet, to enable the growth of the internet to scale. So the idea behind this was to mostly use aggregatable addresses. Here. So local registries would aggregate all the prefixes or all the networks of their customers and announce them to their peers as large blocks. Those large blocks are in address registries lingo called allocations, and the smaller chunks are called assignments, as you can see on this picture. So that is the general idea. However, the problem arose when a lot of people wanted to be multi-homed, but they didn't want to distribute addresses to anyone else. So they wanted to be independent from any of the providers, and therefore there was a different type of address space, which was provider-independent addresses, and that is those smaller blocks there. So right now, the routing table is full of these allocations, and also the smaller provider-independent assignments. However, the routing table is not such a large problem, and at least it's not the one that I want to talk about today. But the shortage of address space is apparently a problem. So right now we have only 12% left. that is about, well, that is 32 big blocks of /8, and that is enough for about 32 months. So in a few years, we are supposed to run out. This is a kind of a prediction. No one can predict, but based on the previous usage rate, so that is assuming that there won't be any hoarding or any rush or any trying to take more addresses than you actually need. So not taking into account human nature, we should have enough until 2012. Well, that's okay, because according to Mayas, the world will end anyway, so we'll be fine. But as we heard in the other presentation. But if you actually are concerned about using the internet after the 2012, then you should be concerned about this. Oops, there are some extra lines here. Well, anyway, so this is just to illustrate the difference between the concepts in IPv4 and IPv6 addressing world. So in IPv4, we are talking about addresses or hosts. So if you connect through your provider, you want to get connection to the internet, you get, if you're lucky, one IP address. If you get IPv6 connectivity from your provider, you will get at least a subnet of the size /64. That's this here. So we are not talking about addresses anymore, because you're supposed to have abundance of addresses in your home. So if you are ever going to use only one subnet in your home, then you're going to get from your provider /64. That means you will have 64 bits to address the hosts within one subnet in your house. And the whole internet today has 32 bits. So you'll have like a network which is much, much bigger than the internet is at home. However, it is considered that you will not have only one subnet in your house, that you will have 2 or more in the near future. And because no one knows how many you will have, the idea is that if you ask your provider today for IPv6 addresses, you will get /48, which is this here. So this will give you 16 bits. So 2 to the power of 16, about 65K subnets. So you'll be able to create 65,000 subnets, and each subnet will have blah, 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 number of hosts. Which is very nice, but if you're an ISP, you will also get only 16 bits to give to your customers. So you can have only 65,000 customers, which is a bit out of proportion, but yeah, there you go. So these are the basics, because now I'll show you the other numbers. So address space distribution for IPv6 is slightly different. If you thought that giving to everyone in their home /48 is wasteful, then yeah, you're agreeing with a lot of people, engineers and architects of the internet, who also think, oh my God, why should we waste all that address space, and are we repeating the mistakes from the past, and so on. And then other camp in that discussion says, well, we are only using 1/8 of the whole IPv6 space. So the first 3 bits are used for dividing the whole address space in 8 chunks, and right now we are using one of those 8 chunks. And these are the current rules, the current policies that people have agreed, because they don't know how to actually use this address space, so they're just saying, okay, let's try it out. So again, we have hierarchical distribution. The central registry, IANA, they give address blocks to regional registries, they give address blocks to local registries, and now there is one more level of hierarchy. The local registries are supposed to give bigger chunks to their ISPs, and then ISPs to assign to the home users, the customers. So if you're just a small ISP and you want IPv6 addresses, you are mostly already a member of the RIPE NCC, you get the /32. If you are Deutsche Telekom, you get /23. Yeah, for a few years. And then again, there was a problem that what if you are not an ISP, but you want to be independent from any other ISP? And for a long time, there was this discussion that actually that shouldn't be the case, and you should trust your ISPs, and blah, blah, blah. You shouldn't be wanting to be multi-homed. And since recently, actually, you can get provider-independent addresses directly from the RIPE NCC. So that's sorted too. So you can see that in European region, there is a lot of activity in the IPv6 arena, let's say. So there are around 2,000 allocations made by the end of 2008 in the whole world, and about maybe 500 more this year. And the routing table has 2,000 entries, which is very, very little compared to IPv4 routing table, which has 350,000 entries, unique entries. So this is like a default free routing table that I'm talking about. So if you want more of those numbers, they are here. This is Herr Döring, one guy from Germany, from SpaceNet, and he's making these statistics all the time and publishing them on conferences like a RIPE meeting. And the RIPE NCC has its own kind of monitoring tool and calculating the number of prefixes and the number of unique AS numbers. And this is just yet another graph to show you that there is a growth. This is like a typical internet graph, but no one wants to put this graph compared to the IPv4 graph, because then you just don't see these lines. It's just like 0.2%. Well, actually, the numbers for traffic, so there are a lot of networks, there are a lot of announcements and stuff, but actually the traffic is 0.2% of any IPv4 traffic measured on the Internet Exchange points. Still, people always like to see how is their country doing. Well, it's good that we're in Germany, because Germany is doing really fine. So Germany has the most total IPv6 allocations in Europe, but also the most new allocations this year were also made to German companies, and then other countries follow. However, if you do want to use IPv6, you can't have only IPv6 address, because then you can only talk to other people who have IPv6 address. And if you have IPv4 connection already, you cannot talk to IPv6 internet. So for a very long time in the future, for 5 or 10 years, or maybe 20 years, the whole network will have to be dual stack. So it will have to run both protocols. So these are stuck together for the future. So the regional registries, apart from distributing these resources, also offer education on IPv6 and information and outreach. As part of that outreach is also my talk on this conference today. So you'll be able to find these links starting from ripe.net or anywhere. However, RIPE NCC and other regional registries don't really decide the rules in which these address resources are distributed. We are only implementing them via Secretariat, and we are part of that whole chain. And the policy is actually made in the grassroots, open way in the communities, and I would like you to get interested in this and take part in creating those policies. The addressing policies are just one part of the story, and this is what I'll talk about. But then there is another part, which is actual standards, and that is done in IETF. So that is also a community-based thing, and it's very open, and you can also take part in that. And it is all very open and transparent, and you are invited to take part in that. And, well, it's all nice and gentle and peaceful. Not. So, who makes these policies? Well, you make them if you choose to do so. but it requires a lot of effort. So it requires a lot of participation, and the network operators who are actually involved in this, they also have day-to-day jobs. So they have to volunteer and go to these conferences and write to mailing lists and participate. So we are also trying to involve more people with the interest and with energy and with the passion for making these policies fair and equal to everyone. So in our region, the forum is called RIPE Community. RIPE stands for Réseau IP Européen, and this year it celebrates 20 years. So this community exists already for 20 years. And it is community for developing IP networks. And in other regions, there are similar conferences and mailing lists and processes. And then it is the direction of creating policy is actually bottom up. So it is a grassroots process, and it's not something that is dictated by evil American corporations or anyone like that on the top. So if you don't like how these policies are, you can take part in changing them. This is the cycle through which all these policies are going through. So if you determine a need for a new policy, you can make a proposal, there will be a discussion, and there won't be any voting. There has to be some kind of consensus. So everyone is arguing until everyone is equally unsatisfied, and they can all say, okay, I can live with that, let's just stop and do something. And then there is implementation. And then they evaluate and say, oh, well, maybe we need to change it again. And then they change it again. But it works. So the example of that, well, I can give you the examples of the past policies that were created like this. I was already talking about it, like the provide independent IPv6 addresses that were not there. So someone said, oh, we need them. I'm writing a proposal. There was a discussion, very, very long one. There was a consensus, but then there was a very long waiting time for the actual implementation. And now they evaluated it and said, hey, but we made a mistake. In the policy, it says only end users can ask for the provide independent space. What about ISPs? Sometimes they also need like a separate range. Oh, now we have to change it. Okay, and then there's a new proposal and the new cycle starts. Another example is there is a need to change the IPv4 policies, because right now these policies are based on several principles, and some of the very important ones are the address space is distributed based on demonstrated need. There should be no reservations, so that need is like a short-term need for the next 2 years, and first come, first served. So you just say, I need 100 addresses, okay, you get them. I need 1 million addresses, oh really? How can you prove that? Oh, well, here are some like bills that I purchased equipment. Okay, there you go, 1 million addresses. And that all works while there is plenty of addresses to give to people. But now we are running out. So what are we going to do? Do we need new policies? And there are now 5 different proposals how to deal with this. So to reserve the last /8, and then to give very, very small chunks to only new companies. And so the existing ones, they have to do something else. They have to go somewhere else for their IPv4 addresses, new ones that they need, so that the new entrance to the industry will be facilitated. And then there are all kinds of different proposals. So if you have strong opinion about this, please take part in these discussions. I'll show you later the website where you can go. So this policy development process is mostly happening in the mailing lists. So someone who creates a policy proposal sends it to the mailing list, and then there is a discussion. If there is some kind of initial support for this, then there is a document which is written, and then the document goes to the review phase, and then other people or the same people get the chance to comment on this again. And if there was a consensus, there is a concluding phase when there is extra time for everyone to give last comments. So all this process is very, well, good in a sense that it is documented. So this is how it looks, everyone knows. There are no secrets, there are no like ways that you can insert something else in here. It is all transparent. Everyone's opinions count the same on the mailing list. And the working group chairs decide if there was a consensus, and they have to make this public, that decision. So it's all transparent, documented, and open to participation. However, it also takes a very, very long time. So it's long and slow, and however open and documented it is also full of buzzwords. So you have to know the terminology to actually take part in this. And it is open, but it is also that somebody's opinion is more important because they're experienced and they have recognition from the community. And so it is also based on, how can I say, well, I'm missing the word, but you have to gain the trust and confidence of those people so that they trust that you know what you're talking about. Reputation, thank you. So this RIPE also, so it has mailing lists, but it also has meetings. So the RIPE meetings are happening 2 times a year. They are 5 days long. There are about 10 working groups, so 10 different topics that are happening there. And there are about 300 to 400 people on each one of them. Very important parts are very long coffee breaks and lunches and social events at the end of every day, where people mingle and exchange experience and steal each other's stuff and make peering agreements and look for another job, things like that. There was one recently in Berlin. Was anyone there? Well, it is, there also, well, it costs about 400 euros for the whole week. There are day tickets, which are cheaper. There are student discounts, and new local internet registries, they can send 2 people for free. So as a part of membership to the RIPE NCC. There are discussions, presentations. Sometimes they happen in the locations that are not accessible to us, but Middle East is also part of the RIPE NCC service region, so one of the meetings was in Dubai. I wasn't there. I was, though, in Amsterdam. A few days ago, there was one meeting in Amsterdam. And it's also possible to participate remotely. There is a webcast of half of the sessions, and other half has a podcast, so just audio. There are stenographers sitting there typing in everything that people say, so that if your English is not so good that you cannot understand native speakers, then like someone is writing it down, or if their English is not so good, then native speakers cannot understand them, then stenographers can, and then everything is written down. There are Jabber channels where you can ask a question, and there are monitors, like people listening to that Jabber channel and like taking part in the discussion. And then if you have a question, they'll stand up to the microphone and ask the speaker. So it's possible to participate remotely. On the other hand, RIPE NCC is a network coordination center for the RIPE community. So we are there in that red circle. This is Queen's Palace in Amsterdam. And our office is relatively small. There are 100 people working for the NCC from more than 20 countries. And our official language is English. Only like about a third of the people are actually Dutch, although we are in Holland. So the RIPE NCC is a regional internet registry. We distribute IP addresses. We do training courses. I'm one of the trainers for the RIPE NCC. We also have, so these are the services only for the members. And then we also have public services. So we maintain the RIPE database, the WHOIS database for the IP resources. We also maintain the KRoot name server, the root for the enum tree, for, well, the root for the enum for the whole world. And what else? And then we also do a lot of information services. So because we are a neutral and impartial body, and members of us are all the internet service providers in Europe, then they trust us with the measurement data and we collect a lot of information, and then we make it public for everyone. So information from all these services is available to the general public. Routing Information Service does something similar to the route views. So it's a gigantic looking glass which has historical overview of the route announcements in the internet. There are like 16 route collectors all over the globe, and then they're listening to the route announcements and making a database out of it. We are doing the host count, measuring the growth of the internet in Europe, DNS monitoring, and the test traffic measurements, where we measure the delay between a lot of boxes in a separate closed network that is hosted by a lot of providers. Another thing that we distribute is AS numbers, and recently there was a change. The 16-bit AS numbers are also running out, and now there are 32-bit AS numbers that are already in use, but it will be more and more in use when there are no more 16-bit ones. So this is just to let you know and to make you prepared for it, and also to tell you a little bit a story about the difference between developing standards and developing addressing policies. So the 32-bit AS numbers were developed in IETF. It was actually, well, if I may say so, a better design than the IP addressing, because the 32-bit AS numbers are just containing also the space of 16-bit AS numbers. So if you have a 16-bit AS number already, you can talk to everyone else who also has a 32-bit AS number. It doesn't matter. You just have to upgrade your hardware, and then it will be possible. Even if you don't upgrade it, then there is some kind of trick and everything is working. It's not like IPv4 and IPv6 that will have to be dual stack. But IETF's processes are also quite long, and they said, yeah, this number will be 32 bits, but we can't decide how to write it. So the registries started distributing 32-bit AS numbers in 2007, and then we were writing it as 16 bits dot 16 bits because it is easier to read. So a lot of, well, few people got those numbers. In the meantime, IETF decided that actually that's not good for some reasons, for some technical reasons, and then the new format was implemented AS plain. So these numbers are now written just like one long big number. So all the people who already got them, and we also had to rewrite all of our tools to start using the new format and so on. So there is some cooperation between us, but these are also two totally different processes. So depending on your tastes and your interests, you maybe want to get involved in creating addressing policies or in the technical standards. And this is the shameless plug. I have IPv6 at home, and I was the first female user of my ISP, Access for All, in Holland. And this is my Fritz box. It's a German box, actually. They are making, well, they are very rare company that actually makes end-user equipment, which is affordable, that runs IPv6 just out of the box. So I just plugged it in and it was all working. So this is my prefix. I have 16 bits to create 65,000 subnets at home. I don't know what for yet, but maybe in the future, maybe my kids will get creative and they'll like start numbering RFID tags of whatever they have, like Barbie dolls and stuff. And since I still have a lot of time, then I'll just use some humor from the participants of our courses who are asked to express what they have learned in a catchy slogan. So this is what they wrote. Okay, I will repeat the question because I didn't have time to give you the microphone. So how many routers out there can support IPv6? I don't know how many can, but I know how many do. And that is one of those previous slides that I have shown. So there are around, well, so between 1,500 and 2,000 AS numbers that are announcing IPv6 actively. So that is the size of the IPv6 internet. Maybe there are more that can, but they don't. Maybe they have IPv6 internally in their network, but that's not visible on the actual internet. And that, of course, is just our view. And we have quite a good view because we are peering on 16 different locations with more than 600 peers, so we get a lot of information. But again, it's not really possible to measure that on the internet scale. There are a lot of researches being done by CAIDA in the States, and we are going to perform a survey soon. So I could get more information later, but I don't know exactly.
And what about the ISPs? I mean, from what I know, most ISPs do not offer direct IPv6 connectivity at all, even if my equipment supports it.
So the question is if the ISPs are offering IPv6 as a service. Well, let me get to that. So it's an eternal problem of the dinosaur and the egg. Should the demand come first or should the deployment come first? So the ISPs are saying, well, my customers don't ask for IPv6. And the customers couldn't care less, because why should they know anything about IPv6 or IPv4? They just want to be connected to the internet. And then some other ISPs say, yeah, we would like to, but the vendors are not supporting it. And the vendors are saying, oh, but the ISPs are not asking for it. So it's quite a complex problem, and the governments are being involved, and the governments are encouraging deployment of the IPv6. But probably it should come from the industry itself. However, the business case for IPv6 is quite, well, not very strong one, because a lot of companies don't look 2 years ahead in the future, and let alone 5 years. So current predictions say maybe we will run out in 3 years. Oh, that's a lot of time. We don't have to buy equipment now that can support IPv6, we'll buy it next time. But that's too late. So I'm not sure which provider in Germany. Does someone else know? Is there a provider in Germany that offers native IPv6? Okay, SpaceNet, yeah. Okay, so he knows 4, so talk to him. And there is also Freenet in France. They offer IPv6 to all of their customers. And now, well, IPv6, Access for All in Holland, but that's like starting slowly. There are other ISPs in Holland that offer IPv6 to their business customers. And, well, maybe if you buy Fritzbox yourself then and try to connect to your provider, maybe they will tell you, yes, of course we have IPv6, but we can't tell that to anyone, because then we would have to give new modems to all our customers, and we can't do that.
But there are several free channel brokers, so it's not really a problem. 6 is the biggest one in Europe, and IE in America.
Yes, so there are other methods. So there is native IPv6, but then there is also IPv6 over tunnels. So you can use Teredo servers and the 6-to-4 method of tunneling, and there is like 6access. They are the tunnel broker, and you can get their services for free. So if you want, you can get IPv6, and I would ask you to do that, to try it out, to demystify it, and then to hack it, because that is the way how it will get improved. Because right now, there are a lot of problems with it still. And the next step is for those that are more socially conscious and socially involved, you can take part in creating policies. it's not only for the network engineers, it's not only for the government employees. Anyone can take part in creating addressing policies and also technical standards. And the internet actually needs new, smart, clever, brilliant people to take part in all these activities. Thank you. Do you have other questions?
I have a question regarding PI space and IPv6. It was a very controversial discussion to keep the routing table short and clean. Why isn't IETF making recommendations regarding that? Why is it that we so low down at RIPE NCC discuss whether we have motorhelming or not?
I cannot say that. It's a controversial question, and there is really no answer. What I've just heard on the last RIPE meeting is that let people multi-home and let them use PI space and let them flood the routing table, because it's better if it grows and if it is too large than if no one is using IPv6. And maybe that is the way to fix it. First you have to break it, and then you will have a problem, then you'll have to fix it. And then in some other fora, there is an attempt to create totally new protocols for routing and addressing on the internet, because the BGP and the IPv4, IPv6 addressing have problems in scaling in themselves, because they are using the same thing as a locator and the identifier. So you cannot do routing without addressing and the addressing without routing. So that kind of breaks things. If everyone wants to be multi-home, then it doesn't scale. So there has to be something else made up, but no one is actually making it. Maybe IETF will come up with it. Maybe some other community, like hackers community, maybe on some other university, they will come up with some brilliant idea. But for now, we are patching the current protocols of the internet.
What do you know about the IPv6 NAT development?
So the NAT for IPv6, yeah, there are developments in IETF. They are writing NAT for IPv6 for all kinds of reasons, security reasons, keeping the same addressing behind your NAT as you would like not transparent. I don't know why. I mean, now the NATs in IPv6 should not be needed for the reasons of the address shortage. But NATs were too intermingled with firewalls, and these functions are too mixed up that now people cannot think, I need a firewall, they think, I need a NAT. On the other hand, it is still necessary to have the network address translations between IPv4 and IPv6, because they cannot talk to each other. So either you're going to have a dual stack everywhere, or some people will have to translate from IPv4 to IPv6 and some other people from IPv6 to IPv4. So these things are actually needed, but just as a transition method to the dual stacked internet, or later maybe only IPv6 internet in maybe 20 years' time.
I mean, actually, they're afraid of that the network is exposed because they have end-to-end connectivity. When you have a great network, then 50,000 routers are exposed. I mean, that's the problem what they have actually. That's why they made NAT 66 and NAT 64.
Yes, but some other people say that that is not a good way of securing your network. So, well, there are always these debates, and some people are going to use it and some people are going to oppose it.
Is this Teredo tunneling method the recommended way of using IPv6?
Native is recommended way.
I mean, if my provider doesn't provide me with native IPv6, there's no way. I mean, if I do not have an... Yeah, maybe you can elaborate on that.
Maybe you can elaborate on that. I can just repeat what he said, but I don't know the technical details.
As it always is said, the market should decide it, and you can, in any case, switch your provider to one who does offer you native IPv6. It's always possible.
Yeah, you also have to switch them because they are censoring,
So this is the new business model. Someone here has to make an ISP which is not censoring, is running IPv6, and is socially friendly. Well, in Holland we have one like that. Yeah, and cheap enough. Well.
Access for all, mentioning access for all. You get free binary news if you're running IPv6 from access for all.
Yes.
So that should,
Yes, there are. So there are other ways of encouraging use of IPv6, and there are localized ways of using IPv6. So, for example, in Finland, there are big networks that are actually using IPv6 for IRC. There are in Czech Republic, there are also big networks, but they're isolated. They're like wireless networks that are interconnected just among themselves, and internally they use IPv6, and then only they have one gateway to the public internet, which is the state telco, and that's why they are using IPv6 among themselves, because they couldn't get connectivity or addresses from their telco provider. So they went for the alternative, and since they were already there, they're using IPv6 in their internal network. And there were other examples. Let me think. Okay, some more questions. Maybe I'll think of something else.
Yeah, they're talking a lot of time about the killer app is missing in IP6, which make the IP6 a big rollout. But I think multicast is a killer app for IP6. But where is multicast? Where is IP6 multicast right now? Okay. Do you have any idea? Can tell?
I'm aware of multicast distribution of Usenet network news, and I'm also I think I'm making a guess probably, but I strongly suspect IPTV to be on multicast, like live transmission of video events on IP networks.
Yeah, there were some attempts of hosting the IPv6 only porn servers. No? Oh, I didn't check. And even if I did, I wouldn't admit it. Well, I'm happy to see that there is so much interest, at least here in this room, for IPv6. And yeah, if you have further questions, you can contact me to this email address. ripe.net is the RIPE NCC address. We have just launched another information site, IPv6 Act Now, which has a lot of news and statistics about IPv6. We are starting to do training courses, and we'll create an e-learning module, but there is already e-learning created by 6this. So if you need education, there is enough material there. There is a lot of information about it, and there are even songs about it. Oh, wait. No, it's just the original, but my sound is very bad. I don't know what can we do about this. Is there the sound plug here? No? You don't know? Okay.
My take on it to a possibly recognizable tune. A long, long time ago, I can still remember when my laptop could connect elsewhere. And I tell you all, there was a day, the network card I threw away, had a purpose and it worked for you and me. But 18 years completely wasted. With each address we've aggregated, the table's overflowing, the traffic just stops flowing, and now we're bearing all the scars and all my trace routes showing stars. The packets would travel faster in cars. The day the routers die. So bye-bye, folks at Ride 55. Be persuaded to upgrade it or your network will die. IPv6 makes me let out a sigh, but I suppose we'd better give it a try. I suppose we'd better give it a try. Now, did you write an RFC that dictated how it all should be? Did we listen like we should that day? Now you back at Ride 54, where we'd heard the same things months before, and the people knew they'd have to change their ways. And we knew that all the ISPs could be future-proof for centuries, but that was then, not now. Spent too much time playing WoW. Oh, there was a time we sat on IRC, making jokes on how this day would be. Now there's no more use for TCP. The day the routers die. So we're singing bye-bye, folks at Ride 55. Be persuaded to upgrade it or your network will die. IPv6 just makes me let out a sigh, but I suppose we better give it a try. Suppose we better give it a try. I remember those old days I mourn, sitting in my room downloading porn. Yeah, that's how it used to be. When the packets flowed from A to B via routers that could talk IP, there was data could be exchanged between you and me. Oh, but I could see you all ignore the fact we'd fill up IPv4, but we all lost the nerve, and we got what we deserve. And while we threw our network kit away, I wished we'd heard the things they say, but all our lives in disarray. The day the routers died, we were singing bye-bye, folks at Ride 55. Be persuaded to upgrade it or your network will die. IPv6 just makes me let out a sigh, but I suppose we better give it a try. I suppose we better give it a try. Saw a man with whom I used to peer, asked him to rescue my career. He just sighed and turned away. I went down to the net cafe that I used to visit every day, but the man there said I might as well just leave. Now we have all lost our purpose. My Cisco shares completely worthless. No future meetings for me at the Hotel Krasnopolsky. And the men that make us push and push, like Jeff Houston and Randy Bush, should have listened to what they told us the day the routers died. We're singing bye-bye, folks at Ride 55. Be persuaded to upgrade it or your network will die. IPv6 just makes me let out a sigh, but I suppose we better give it a try.
Thank you. See you later.